If the moon suddenly disappeared, Earth would still circle the sun. The oceans would still rise and fall under the pull of the sun's gravity. But the planet you know, the climates, the seasons, the stability that made life possible would collapse into chaos. The moon is not just a glowing disk in our night sky. It is one of the most important reasons Earth is habitable at all. For billions of years, the moon has been more than a companion to Earth. It has been a stabilizer, a shield, a regulator, and a guide. Without it, our planet would be radically different, perhaps too unstable to allow complex life to evolve. When most people think of the moon, they picture tides, eclipses, or the Apollo astronauts. But the moon's influence runs much deeper. It has shaped Earth's axis, its climate, its oceans, even the biological rhythms of life, the rise and fall of civilizations, the timing of migrations, the very way life has evolved. All of these have been quietly guided by our lone satellite. The moon was born out of a cataclysm, a colossal collision that left Earth forever changed. Since then, it has governed more than just the rhythm of the tides. It has acted as a cosmic anchor, preventing Earth from wobbling wildly in space. It has slowed our rotation, stretched our days, and carved patterns into the oceans. Its gravity has been a quiet architect of habitability. How the moon has been essential for life on Earth, tracing its story from its violent birth to its enduring role today. One of the most important things the moon has ever done for life is something most people never notice. It has held Earth steady. Earth is tilted. Our planet doesn't spin upright like a toy top. Instead, it leans at an angle of about 23.5 degrees. That tilt is the reason we have seasons. Without it, the sun's rays would strike each region of Earth almost the same way year-round. There would be no winter snows, no summer heat waves, no spring thaws. Life, as we know it, would be unimaginably different. But tilt also means instability. A spinning body's axis tends to wobble over time, like a slowing gyroscope. Earth is no different. Left unchecked, its tilt could swing dramatically, sending polar ice sheets into the tropics and turning the equator into frozen wasteland. The moon prevents this chaos. Its gravitational pull acts as a stabilizing force on Earth's spin, dampening the wild variations that would otherwise occur. With the moon in place, Earth's tilt oscillates gently within a narrow range, typically between 22 and 24 degrees. These small shifts are enough to drive ice ages and warm periods, but not enough to make the planet uninhabitable. Without the moon, simulations show Earth's tilt might wander anywhere from 0 degrees, no tilt at all, meaning no seasons, to more than 80 degrees, where the poles would point almost directly at the sun for parts of the year. Such swings would devastate climates. Oceans could freeze solid in one era, then boil away in another. stability, the very foundation of complex life, would be impossible. To understand just how crucial the moon has been, look at Mars. Unlike Earth, Mars has only tiny moons, Phobos and Deimos, captured asteroids too small to matter. As a result, Mars's tilt has swung wildly over millions of years, shifting by as much as 60 degrees. These shifts have caused violent climate swings, with ice caps melting, refreezing, and shifting location entirely. On Earth, life could not have survived such upheavals. The moon has spared us from this fate. By anchoring Earth's axis, it has given us long-term stability, allowing ecosystems to adapt, evolve, and thrive across millions of years. Seasons are more than just weather patterns. They are life cycles. Plants grow and reproduce based on the tilt-driven march of spring and summer. Animals migrate, hibernate, and breed in response to changing day lengths. Human civilizations have relied on seasonal cycles to plant crops, harvest food, and measure time. Without stable seasons, none of this would be possible. Imagine a world where within a few millennia, winter might vanish entirely, only to return centuries later with crushing ice sheets stretching into the tropics. Such instability would wipe out agriculture and prevent civilization from taking root. The moon's stabilizing presence has therefore been one of the most profound contributors to life on Earth. It has turned a chaotic planet into a predictable one, predictable enough for biology to flourish and for intelligence to eventually rise. One of the keys to evolution is time. Complex organisms require millions of years to develop, but time alone is not enough. They also need stable conditions. If environments change too violently or too often, life is constantly reset, stuck in the rut of simple forms. Thanks to the moon, Earth has offered long stretches of relative stability. Ice ages come and go, but slowly, over tens of thousands of years. Warm periods last long enough for forests, grasslands, and coral reefs to expand. Evolution works on these timescales. Without stability, complex multicellular life, plants, animals, humans, might never have had the chance to appear. In a very real sense, the moon gave life the time it needed to grow from microbes into minds. When most people think about the moon's influence on Earth, the first thing that comes to mind is the tides. Twice a day, the oceans rise and fall, drawn by the moon's pull. But tides are far more than a curiosity for fishermen or surfers. They are one of the deepest ways the moon has shaped the history of life. Tides are caused by gravity. The moon pulls on Earth's oceans, stretching them into bulges. One bulge forms on the side of Earth facing the moon, where the pull is strongest. Another forms on the opposite side, where the moon's gravity is weakest, creating a kind of rebound effect. As Earth rotates through these bulges, coastlines experience rising and falling waters, high tides and low tides. The sun also plays a role, but it is the moon that dominates. Solar tides exist, but they are less than half as strong as lunar tides. Without the moon, the daily rise and fall of the oceans would be faint, irregular, and much less powerful. Billions of years ago, the tides were even stronger. When the moon first formed, it orbited much closer to Earth than it does today. As a result, tides were immense, sweeping hundreds of kilometers inland and then retreating over and over again. This constant flooding and drying created a dynamic, shifting environment unlike anything we see today. And it was in these tidal zones that many scientists believe life first took crucial steps. Life began in water, but at some point, chemistry had to make the leap from simple molecules to self-replicating systems. Tidal zones offered the perfect setting. As seawater washed into shallow pools, it left behind concentrated mixtures of minerals, salts, and organic compounds. Then, as the tide retreated, the pools evaporated, drying the chemicals into dense films. This cycle of flooding and drying repeated endlessly, like nature's own experiment. Each cycle provided opportunities for molecules to link together, break apart, and form new combinations. Over millions of years, these tidal environments could have fostered the first proto-life. Simple molecules that stored energy, carried information, and eventually began replicating themselves. Tides also brought energy. The constant movement of water delivered nutrients, stirred up sediments, and created shifting gradients of temperature and chemistry. Life thrives on gradients, differences in conditions that can be exploited for energy. In tidal pools, early molecules may have harnessed these changes to build complexity, while hydrothermal vents deep in the ocean are another strong candidate for life's birthplace. Many researchers argue that tidal zones offered something vents could not: cycles. Day after day, week after week, the tides delivered a natural rhythm. That rhythm, governed by the moon, may have been the clock that set life in motion. Over time, tides did more than nurture life at the molecular level. They sculpted the very geography of Earth's coastlines. Every tide carries sediment, shifting sands and mud, building deltas, eroding cliffs, and reshaping estuaries. Without strong tides, shorelines would be simpler, more static. But the moon has given Earth restless, ever-changing coasts. These shifting zones became cradles of biodiversity, habitats where land and sea meet, mix, and compete. Mangrove swamps, salt marshes, tidal flats, all of these ecosystems exist because of the moon. They are among the most productive habitats on Earth, supporting fish nurseries, bird migrations, and vast webs of life. Consider the horseshoe crab, a species that has survived largely unchanged for hundreds of millions of years. Its entire reproductive cycle depends on the tides. Each year, under the full moon and the high spring tides, horseshoe crabs crawl onto beaches to lay their eggs in the wet sand. Migratory birds time their journeys to feast on these eggs. And countless other species are woven into this rhythm. The moon, through the tides, has dictated the behaviors of species for as long as life has existed on land. For billions of years, life remained in the oceans, but eventually, some organisms ventured out of the water. Tidal zones may have been the testing grounds for this transition. Creatures stranded in tidal pools had to adapt to drying out, to sudden changes in salinity, and to exposure to air. These pressures encourage traits like tougher skins, the ability to breathe outside of water, and limbs strong enough to move across mudflats. In other words, the moon may have indirectly guided the evolution of land animals. Without the stress of tides, the push to adapt might never have been strong enough to drive life onto dry ground. Even today, countless organisms follow the rhythm of the moon. Grunion fish spawn only during specific tides after the full moon. Coral reefs around the world release their eggs and sperm in synchronized spawning events tied to lunar cycles. Sea turtles crawl ashore under moonlight, laying eggs on beaches shaped by tidal patterns. Life has not only adapted to the tides, it has been written into its code. From the level of DNA repair cycles to the migrations of whales, biology is entangled with the moon's pull. Long before astronomy or mathematics, humans learned to read the moon. Its phases provided the first calendars, its cycles guiding hunting, fishing, and farming. Tides, too, became a tool of survival. Coastal peoples knew when to harvest shellfish, when fish would be trapped in tidal pools, when the waters would rise high enough to bring boats inland. Some of the earliest great civilizations, Mesopotamia, Egypt, the Indus Valley, China, grew along rivers and coasts, places shaped by tides. Even today, more than 2/3 of the world's population lives within 100 kilometers of the sea. Ports, trade routes, and economies have always been tied to tidal waters. The moon, silently pulling on our oceans, has shaped not only ecosystems, but the course of human society. When Earth first formed, a day was not 24 hours long. It was closer to 6 hours. The young planet spun so rapidly that sunrise and sunset came 4 times as quickly as they do now. Life, if it had existed then, would have faced a very different world, one of dizzying rotations, ferocious winds, and extreme weather patterns. The reason our days are now 24 hours long is the moon. The moon's gravity doesn't just raise tides, it also pulls back on them. As Earth rotates, the tidal bulges it creates are carried slightly ahead of the moon. The moon's gravity then tugs on these bulges, creating friction that slows Earth's spin. This braking effect has been happening for billions of years. Slowly, Earth's rotation has lengthened from 6 hours to 10 to 16 to 24. every few tens of thousands of years, our days grew just a little longer. As Earth's spin slows, the moon drifts farther away. Even now, it recedes by about 3.8 centimeters per year. This dance between planet and satellite is one of the most delicate gravitational relationships in the solar system. It has given Earth a rhythm, not too fast, not too slow. Without the moon, Earth might still spin with dizzying speed. Winds would scream across the surface. Storms would be constant, and climates would be chaotic. With days stretching only a few hours, life would struggle to adapt. The moon's steady breaking has given Earth long, stable days and nights, a cycle that life could rely on. Almost every living thing on Earth follows a 24-hour cycle, from humans to plants to bacteria. Organisms have internal clocks that tell them when to sleep, when to eat, when to grow, and when to reproduce. These cycles are called circadian rhythms, from the Latin circa diem, meaning about a day. Circadian rhythms are tuned to light and darkness, but their length, 24 hours, is no coincidence. They evolved because Earth's day lengthened under the moon's influence. Had Earth kept spinning rapidly, life might have evolved to much shorter cycles, perhaps 4-hour or 6-hour biological rhythms. That kind of world would have produced entirely different forms of behavior, metabolism, and ecology. Plants are among the most direct beneficiaries of 24-hour days. Photosynthesis, the process by which plants turn sunlight into energy, depends on reliable cycles of light and dark. A too short day would not allow plants enough time to store energy. A too long night would cause them to starve. The moon, by slowing Earth's spin, created days and nights of manageable length. That change allowed photosynthetic organisms to flourish, filling the atmosphere with oxygen and laying the foundation for animal life. Animals, too, are tied to the length of the day. Nocturnal hunters like owls and lions rely on the cover of darkness. Diurnal species like humans and eagles depend on daylight. The alternation of day and night has created niches, roles that species occupy, and has driven biodiversity. If Earth's rotation had remained rapid, nights would be only a few hours long, perhaps too short for nocturnal life to evolve. The richness of ecosystems would be diminished. Humans are profoundly tied to the 24-hour rhythm. Our brains release hormones like melatonin when it grows dark, making us sleepy. Our body temperatures rise with daylight, preparing us for activity. Even in caves without sunlight, humans continue to follow cycles close to 24 hours, proof of how deeply it is ingrained. Without the moon's influence, our biology might be alien to us. We might sleep in bursts throughout the day, never resting for long, never awake for long. Civilization, with its reliance on coordinated activity, would be nearly impossible. The cycle of day and night is the oldest clock. Long before calendars and mechanical watches, people measured life by the rising and setting of the sun. Agriculture, religion, navigation, all depended on this rhythm. By stabilizing Earth's rotation, the moon gave humanity not just a physical cycle, but a cultural framework. Our very concept of time flows from the balance the moon created. The moon is still slowing Earth down. Millions of years from now, days will be longer than 24 hours. Billions of years from now, Earth may become tidally locked, showing only one face to the moon, just as the moon does to us. If life still exists then, it will face a new rhythm. But for now, we live in the golden balance, long days and nights, perfectly suited for the life that has evolved here. When people look at the moon through a telescope, the first thing they often notice are its scars. The lunar surface is pockmarked with craters of all sizes, from tiny dimples to basins hundreds of kilometers wide. Each one is a record of an impact, an asteroid or comet that smashed into the moon at tremendous speed. Those craters are more than history. They are evidence of the moon's quiet role as a shield for Earth. Billions of years ago, the solar system was a chaotic place. Leftover debris from planet formation still filled space, crashing into planets and moons with devastating force. Earth was no exception. In fact, our planet was struck so often that entire oceans may have boiled away multiple times. But Earth had an ally. Orbiting nearby, the moon intercepted many of these impacts. Some asteroids that might have hit Earth instead slammed into the lunar surface. The result is the scarred face we see today. The moon did not stop every collision. Earth was still hit many times, often with catastrophic results. But without the moon, the number of direct impacts would have been far higher. The probability of Earth being sterilized, its surface wiped clean of life, would have increased dramatically. Consider the size of the Imbrium Basin, one of the largest craters on the moon. It is over 1,100 kilometers wide. An impact of that scale on Earth would have destroyed continents, boiled oceans, and perhaps set back life by billions of years. But it didn't hit Earth. It hit the moon. Again and again, the moon absorbed blows that might have been fatal for us. The moon also helps by exerting its own gravity. While small compared to Earth, the moon's mass is enough to alter the paths of incoming objects. In some cases, it nudges asteroids away, sparing Earth. In others, it draws them in, sacrificing itself to protect the planet. This gravitational influence is subtle, but over billions of years, it has made a difference. When we compare Earth with planets that lack large moons, the contrast is stark. Mercury and Venus, with no significant satellites, have been struck repeatedly throughout history, their surfaces scarred and burned. Mars, with only 2 tiny moons, bears the colossal scar of the Hellas Basin, evidence of impacts that shaped its fate. Earth's surface, by contrast, shows fewer massive craters. Some of that is due to erosion and plate tectonics erasing scars, but some is thanks to the moon. Its presence has reduced the number of catastrophic impacts, giving life the chance to thrive. Earth has endured mass extinctions, asteroid strikes, volcanic winters, ice ages. Yet life has always rebounded. One reason may be that the most extreme impacts, the ones that could have sterilized the planet completely, were intercepted by the moon. Without that protection, Earth might have been reset to zero again and again. Complex life might never have had the continuity needed to evolve. The moon, by taking hits for us, preserved the stability of Earth's biosphere. 66 million years ago, an asteroid struck Earth near what is now the Yucatan Peninsula, causing the extinction of the dinosaurs. That event shows how devastating impacts can be, even when they do not destroy all life. Now imagine dozens of impacts of similar scale or larger throughout history. If not for the moon, Earth might have endured many such cataclysms. Instead, life had long stretches of peace, punctuated by rare disasters. Those long stretches allowed ecosystems to diversify, evolve, and create the rich web of life we know today. Every time humans look at the moon, they see its scars. Ancient civilizations did not know the cause, but they sensed meaning. The moon was marked, imperfect, mysterious. For some cultures, those marks were the footprints of gods. For others, they were omens. In truth, those craters are a record of our survival. Each one represents an impact we did not suffer. Each scar is proof that Earth has been spared again and again. The moon's cratered face has also inspired reflection. By seeing another world marked by violence, humans have been reminded of their own fragility. The moon, in this sense, has shaped not just biology, but culture, teaching us humility, vulnerability, and awe. The moon's pull on the oceans does more than create tides. Over geological timescales, it has shaped entire marine systems, carving coastlines, influencing currents, and fostering ecosystems that would not exist without its constant tug. Each tide does more than raise and lower water. It stirs the oceans, mixing surface waters with deeper layers. This mixing brings nutrients from the depths up to the surface, where sunlight fuels photosynthesis. Phytoplankton, the microscopic plants of the sea, depend on this renewal. Without nutrients, they could not thrive, and without them, the entire ocean food chain would collapse. Thus, the moon indirectly feeds the oceans. Every whale, every fish, every seabird ultimately depends on this lunar-driven cycle. Tidal forces create estuaries, places where rivers meet the sea. These brackish waters are some of the richest ecosystems on Earth. They serve as nurseries for fish, crabs, and countless other species. The rise and fall of tides flush these systems with fresh nutrients, keep them oxygenated, and protect young organisms from predators in open waters. The moon's rhythm sustains these safe havens, making estuaries cradles of biodiversity. For as long as humans have travelled, the moon has been a guide. Sailors tracked its phases to measure time. Navigators used its position in the night sky to fix their bearings. Even today, some indigenous communities continue to rely on lunar knowledge for orientation. Before compasses, before GPS, the moon lit the path of explorers. It made the night less dark, the horizon more visible, the ocean less vast. Without it, early navigation might have been impossible. The moon also shaped the practice of seafaring itself. Fishermen timed their expeditions according to tides. Ports were built in places where tidal ranges were favourable. Whole economies rose around the predictability of the moon's pull. Civilizations that mastered the tides mastered the seas. From Polynesian voyagers to Viking explorers, lunar knowledge was power. The moon's phases provided humanity's first reliable calendar. Unlike the sun, whose position changes slowly, the moon cycles visibly within weeks. Ancient people noticed that from new moon to full moon to new again, about 29.5 days passed. This became the basis of lunar months, used by civilizations from the Babylonians to the Mayans. Even today, many calendars, including the Islamic and traditional Chinese systems, are still lunar-based. Cultures across the world have tied their traditions to the moon. Full moons mark harvest festivals, hunting rituals, and religious observances. In India, Diwali often aligns with the new moon. In Islam, Ramadan begins with the sighting of the crescent. In Europe, Easter is set by the full moon after the spring equinox. The moon has been humanity's clock, its storyteller, and its sacred sign. The moon's constant cycle of waxing and waning has made it a universal symbol of renewal, death, and rebirth. Many cultures saw it as a goddess. Artemis in Greece, Selene in Rome, Chandra in India. Others linked it to fertility, to tides of blood and birth, to the mysteries of life itself. Its light has inspired poets, guided shamans, and comforted wanderers. It is not only a physical body, but a cultural cornerstone, woven into myth and meaning. While some myths about the moon's influence on humans, such as the lunacy of full moons, are exaggerated, biology does carry traces of lunar rhythms. Women's menstrual cycles, averaging about 28 days, align closely with the lunar month. For much of human history, this alignment tied fertility and reproduction to the phases of the moon. Studies show that even today, human sleep patterns can shift with the moon. Bright full moons reduce deep sleep in some people, a lingering sign that our ancestors once relied on the moon's light to extend activity into the night. The moon, in subtle ways, still shapes how we live, rest, and reproduce. When people think about climate, they imagine the sun, the atmosphere, or greenhouse gases. But behind the scenes, the moon has quietly shaped Earth's climate for billions of years. As covered earlier, the moon keeps Earth's tilt stable. Small variations in tilt drive long-term climate cycles, such as ice ages. Without the moon, Earth's tilt could swing wildly, producing catastrophic climate shifts. Imagine the poles pointing directly at the sun for decades. Summers would be unbearable, winters endless, and ecosystems would collapse. The moon prevents such extremes, keeping Earth's climate within habitable bounds. Even with the moon's stabilizing influence, Earth's orbit and tilt still change over tens of thousands of years. These are called Milankovitch cycles. The moon moderates the effects of these cycles, preventing the most extreme swings. During the last 2.5 million years, these cycles have driven the advance and retreat of ice sheets. Yet through it all, Earth remained a planet of life, not a frozen wasteland. The moon helped ensure that balance. Ocean currents are the planet's conveyor belts, moving heat around the globe. The Gulf Stream, for example, carries warm water from the tropics toward Europe, making its climate far milder than other regions at the same latitude. The moon plays a role here too. By driving tides, it stirs the oceans and keeps currents moving. Without this tidal input, circulation would weaken and climates worldwide would shift dramatically. In the deep ocean, tides mix waters that would otherwise stagnate. This mixing helps regulate carbon dioxide and oxygen levels, influencing not just climate, but also the chemistry of the entire biosphere. In this way, the moon acts as a global climate moderator. The great ice ages of the past were triggered by changes in Earth's orbit and tilt, but their timing and severity were influenced by the moon. By keeping Earth's tilt within a narrow range, the moon ensured that ice ages were long, but survivable. Had Earth's tilt swung by 60 or 80 degrees, glaciers might have stretched to the equator, wiping out most life. Instead, ice sheets advanced and retreated in cycles that ecosystems could endure. Life adapted to these changes. Species migrated with shifting climates. Forests expanded and contracted. Deserts grew and shrank. Through it all, stability on a geological scale allowed biodiversity to survive and flourish. The moon did not eliminate climate change, but it kept it within limits life could handle. Look across the solar system, and Earth stands out. Venus, with no moon, is a furnace of runaway greenhouse gases. Mars, with only tiny moons, has swung through wild climate shifts that left it cold and barren. Earth, with its large moon, has remained habitable for billions of years. Oceans, forests, ice caps, and deserts have come and gone, but life has endured. In the deep history of Earth, the moon has been a quiet regulator. Its pull has kept climates moderate, oceans moving, and ecosystems resilient. Without it, Earth might resemble its neighbours, unstable, barren, and lifeless. Life on Earth began with single-celled organisms. For billions of years, bacteria and algae dominated the oceans. But eventually, life became more complex. Plants, animals, and eventually humans appeared. The moon, through its many influences, played a key role in this transition. One of the great mysteries of biology is how life went from simple cells to complex multicellular organisms. Stable environments are thought to have been critical. The moon's influence on Earth's tilt, tides, and rotation provided that stability. By moderating climate swings, the moon allowed ecosystems to remain relatively steady for millions of years at a time. This gave evolution the long windows it needed for complexity to emerge. Without stability, evolution would have been constantly reset, keeping life simple. Complex life requires oxygen. Around 2.4 billion years ago, photosynthetic organisms began filling the atmosphere with oxygen in what scientists call the Great Oxidation Event. Here again, the moon played a background role. By slowing Earth's rotation, it lengthened days, giving photosynthetic organisms more time each cycle to generate oxygen. Over time, this helped create an atmosphere where animals could breathe and thrive. Tidal zones also provided unique evolutionary challenges. Organisms stranded in tidal pools had to adapt to exposure, salinity changes, and fluctuating temperatures. These pressures encouraged innovations like stronger shells, better respiration, and mobility. Some of the earliest steps toward land-based life likely came from these tidal stresses set in motion by the moon. About 541 million years ago, life suddenly diversified in what is known as the Cambrian explosion. Nearly every major group of animals first appears in the fossil record during this period. Scientists debate what triggered it, but one factor may have been the stable climates made possible by the moon. With stability, ecosystems grew richer, competition intensified, and evolution accelerated. Roughly 400 million years ago, plants and animals began colonizing land. Tidal ecosystems had already prepared organisms for life outside the sea. Amphibians and early plants carried with them adaptations honed by lunar-driven cycles, resistance to drying, the ability to breathe air, and structures for moving on solid ground. Fast forward hundreds of millions of years, and the moon was still shaping evolution. The stability it provided allowed mammals to diversify after the extinction of the dinosaurs. Eventually, humans appeared, a species dependent on predictable seasons, long days, and steady climates. Without the moon, our evolutionary story might have ended at microbes, never progressing to intelligence. Even today, many species time their reproduction to the moon. Corals spawn in synchrony with lunar phases, ensuring that eggs and sperm meet in vast clouds. Grunion fish swarm beaches under full moons to lay eggs in the sand. Sea turtles follow lunar light to find nesting grounds. These behaviors are not accidents. They are products of millions of years of adaptation to the moon's cycles. Evolution has written the moon into the DNA of countless species. For humans too, the moon mattered. Its light extended the day, allowing early people to hunt, gather, and socialize after dark. It shaped myths, guided migrations, and influenced when communities planted and harvested. The moon was not only a physical force, but also a companion in the evolutionary journey of our species. To understand the moon's importance, imagine Earth without it. Days would be short and frantic, only a few hours long. Seasons would swing chaotically, with ice caps sometimes stretching to the equator. Tides would be weak, offering little evolutionary push. Climate would shift too violently for complex ecosystems to endure. Evolution might never progress beyond single-celled life. The moon turned chaos into rhythm. It gave Earth stability, cycles, and time, the three ingredients needed for life to grow complex. By the time humans appeared, the moon had already been shaping life for billions of years. But with the rise of civilization, its influence took on new dimensions. It became not just a natural force, but a central figure in human culture, science, and identity. For early humans, the moon was the brightest object in the night sky. It rose and set, waxed and waned, and appeared in predictable cycles. To hunter-gatherers, this regularity was both mysterious and useful. The moon provided light for night hunting and traveling. Its cycles gave structure to time, long before written calendars. Archaeological evidence suggests that as far back as 30,000 years ago, humans were marking lunar phases on bones and stones. These markings may represent the earliest attempts to track time, the first calendars. When farming began about 10,000 years ago, the moon's cycles became even more important. Farmers needed to know when to plant and harvest. The moon's phases offered a reliable guide. Many traditional farming systems tied specific crops to certain phases of the moon, a practice that persisted for millennia. The link between the moon and agriculture was not just practical, but spiritual. In many cultures, lunar deities were associated with fertility, growth, and abundance. Across cultures, the moon became a symbol of power, mystery, and renewal. Its cycles mirrored the cycles of life and death, darkness and light. In Mesopotamia, the moon god Sin, or Nana, was worshipped as the keeper of time. In ancient Egypt, the moon was linked to Thoth, the god of wisdom and writing. In Greece, Selene and Artemis represented the moon as divine feminine figures. In India, the moon god Chandra was central to Hindu cosmology. Among indigenous peoples worldwide, the moon was tied to hunting, fertility, and seasonal cycles. Every culture saw its own reflection in the moon. It was not just an object in the sky, but a presence woven into human life. Even today, many of the world's major festivals are tied to the moon. The Islamic calendar is purely lunar, with months beginning at the sighting of the crescent moon. The Chinese calendar is lunisolar, with the Lunar New Year and Mid-Autumn Festival centered on moon cycles. Easter in Christianity is determined by the full moon after the spring equinox. The moon's rhythm has shaped human ritual for as long as we have kept records. The moon was humanity's first laboratory. By watching its phases, eclipses, and movements, ancient astronomers learned to predict celestial events. Babylonian priests tracked the moon to forecast omens. Greek philosophers used lunar eclipses to argue that Earth was round. These observations were the foundations of science. Astronomy, mathematics, and timekeeping all grew out of humanity's fascination with the moon. The word month itself comes from the moon. Roughly 29.5 days pass between new moons, a lunar month. Ancient calendars around the world were based on this cycle. Even as solar calendars took over, lunar months remained embedded in language and tradition. To this day, the moon continues to measure our sense of passing time. The moon has always inspired storytelling. Folk tales describe it as a rabbit, a face, or a god. Poets have compared it to love, loss, and longing. Philosophers have seen in it a mirror of human destiny. By gazing at the moon, humans learned to imagine beyond Earth. It was the first other world we wondered about, the first destination in the sky. From ancient myths of chariots carrying the moon across the heavens, to modern rockets carrying astronauts across space, the moon has been our eternal target. It is both ancient and modern, mystical and scientific. Without the moon, human culture might have lacked its most constant symbol of mystery and exploration. With the rise of modern science, the moon shifted from being a mystical symbol to a physical world. Yet its importance only deepened. By studying the moon, humanity has uncovered not just its secrets, but also the story of Earth itself. In 1609, Galileo Galilei turned his telescope to the moon. What he saw changed history. Instead of a perfect smooth sphere, as philosophers once imagined, the moon was scarred with mountains, valleys, and craters. This discovery shattered the old belief that celestial bodies were flawless and divine. The moon became a real place, a world with landscapes as rugged as Earth's. It was proof that the heavens were not fundamentally different from the Earth below, a turning point in science. Even before telescopes, the moon taught us about our planet. During lunar eclipses, when Earth passes between the sun and the moon, the shadow cast on the moon is always round. Ancient Greek thinkers used this as evidence that Earth is a sphere, not flat. The moon was thus an early witness in humanity's quest to understand the cosmos. By studying the moon, scientists began to understand how planets form. The craters revealed a violent history of impacts. The lack of atmosphere explained why weather and erosion never erased them. Through the moon, we learnt that impacts shape every world, that atmospheres protect surfaces, and that time itself is recorded differently on different planets. In the 20th century, evidence began to point to a dramatic origin story, the giant impact hypothesis. According to this theory, the moon formed when a Mars-sized body collided with the early Earth about 4.5 billion years ago. The debris from this cataclysm coalesced into the moon. If true, the moon is literally a piece of Earth, born from the same rock and dust. The very event that created the moon also reshaped Earth, giving it its tilt and seasons. The moon's existence is inseparable from our planet's destiny. In the mid-20th century, the moon became the ultimate prize in the space race. The Soviet Union stunned the world in 1959 by sending the first spacecraft to photograph the far side of the moon. Soon after, American astronauts set their sights on walking its surface. On July 20th, 1969, Neil Armstrong set foot on the moon. His words, "One small step for a man, one giant leap for mankind," marked a turning point in human history. For the first time, life from Earth had reached another world. The moon was not chosen simply because it was close. It was chosen because it has always been our guide. From the first calendars to the first telescopes, from myths to science, the moon has been the bridge between the Earth and the heavens. Landing on the moon was humanity's natural first step into space. The Apollo missions brought back over 380 kilograms of moon rocks. These samples revolutionized science. They revealed the moon's age, its volcanic past, and its composition. They confirmed theories of planetary formation and provided a timeline of the solar system's violent youth. Every piece of knowledge about the moon is also knowledge about Earth. By studying lunar rocks, we study our own origins. The quest to reach the moon also drove technological progress. Rockets, satellites, computers, telecommunications, all advanced rapidly because of the race to the moon. In this way, the moon has shaped not only biology and culture, but also modern technology. When humans saw Earth from the moon for the first time, captured in the famous Earthrise photo, it changed our perspective forever. Earth appeared as a fragile blue sphere against the blackness of space. That image, made possible by the moon, inspired the modern environmental movement. It reminded humanity of our shared home and our shared fate. Today, nations and companies are planning to return to the moon. Bases, telescopes, and even industries may one day be built on its surface. Once again, the moon is acting as humanity's stepping stone, this time toward Mars and beyond.